Hey, boys and girls, we're going to be taking a look again at constant rate of change. And this is just going to be a follow-up to the activity that we did in our previous day. But I want to kind of just give you a little bit of a review. So we're going to use a video, and I hope you can follow along with us. So if you remember, the constant rate of change is where we're trying to figure out how much a value changes and then compare that to another set of data. Okay. So what we're doing first here is let's go down through. We have the age in years for our first example, and we're comparing that to height. So as we can see here, the age in years is going from 9 to 10, and we would say that that is a change of +1. Then the height is changing as 54 goes to 56, and that would be by 2 inches. Now what we're going to do is we're going to compare this. So from 10 to 11 is also an increase of +1. 11 to 12 is an increase of +1. From 56 to 58, we're increasing by 2. And from 58 to 60, we're increasing by 2. Now, in order to find the constant rate of change, we usually say what is the change in y over the change in x. And when we look at a table, typically this first column here is going to be the x value, and the second is going to be the y value. So in order to find the change in y over the change in x, we are simply going to take the number that is the change for y, so that would be 2, and we're going to place that over top of the value that's the change for the x, which in this case is going to be 1. So we would then say that our constant rate of change for this is going to be 2 over 1, or if we use our labels, 2 inches for every year, or 2 inches per year. Now the second example here, the second example here starts off with zeros. And again, we're going to be looking for what is the change in y over what is the change in x. And the temperature is going to be our y, and the time is going to be the x, or the input and the output. So our change in x is going to be from 0 to 4. We would say that that's a +4. From 4 to 8 is still +4. And from 8 to 12 is still +4. The nice thing is, if this continues to stay the same, then we really don't have to worry about checking our other values. Now, from 0 to 3, we would say that that's an increase of 3. 3 to 6, still an increase of 3. And from 6 to 9, an increase of 3. So again, our change in y is going to be 3 here. So we have 3 degrees. 3 degrees. Let me erase that. So 3 degrees Celsius for every 4 hours. So our rate of change is 3 degrees Celsius every 4 hours. Now, if we had to get that down to a unit rate, okay, so if we had to get this down to a rate of 1, we would divide 3 divided by 4, 3 divided by 4. 4 cannot go into 3, so we add our decimal and a 0. 4 can go into 30 7 times, so we place our columns vertically. 7 times 4 is 28. Subtract the values, we get 2. We're not allowed to have a remainder. We're dealing with decimals, so we're going to bring down another 0. Doesn't change the value, it's still 3. 4 goes into 20 5 times. Subtract the value, and we end up with no remainder here. So we could say that the change, the rate of change here is 0.75 degrees Celsius every 1 hour. All right, and this would be our unit rate. Now the last example here gives us a graph, and the graph shows the cost of renting movies. We want to find the constant rate of change for the graph and explain what these points mean. So the constant rate of change is the amount of change vertically. So this would be our delta y, or change in y. And again, it's going to be over the change in x. So the change in y here is we're going to go up 5. And we're going to go over 1. So the vertical box is worth 5 and the horizontal box is only worth 1. So it's up 5 over 1. So it's 5 over 1, or $5, because the label is dollars, for one movie. So that would be our unit rate, or the rate of change. For every movie, it's going to go up $5, or $5 per movie. So then when we look at these points, 0, 0, to me, that means that we didn't get any movies. We didn't rent a movie. So therefore, we didn't have to pay any money. So we rented 0 movies. And the cost is $0. So then in your head, let's go ahead and solve this one. 2 and 10. Well, the 2 is in the X value, so that's the number of movies. So I'm sure you've already guessed that we have rented 2 movies. And in renting 2 movies, it is costing us $10. Well, I probably should have put in there 4 for $10. And that would just make sense, since our unit rate, or our constant rate of change, is $5 per movie. 2 movies would be $10. So I hope you found this to be informative. I hope it helps clarify a couple of things. We gave you 3 examples. And as always, if you need any assistance, please make sure that you reach out, and we'll be more than happy to help you out.